All right, we're gonna get started. Again, you are working on that worksheet that was posted yesterday. They are some tough problems. The answers are not nice numbers all the time. Um, but we do that with system of equations because graphing doesn't work all the time with ugly numbers. It's hard to see unless you get a computer to actually graph it for you, which is an option. I mean, you have access to Google Sheets and some of you have graphing calculators. So, I mean, that is an option on checking your work. Uh, but let's go over a problem like we were doing yesterday, which I put over here, and then a problem that's slightly different. You'll note that in number 2 here, we don't have a second one that says y equals something, so we have to rework some things here. And this one's actually probably easier to do than this one over here, but we'll get to that second. So just as a reminder, this is your system of equation. It is two equations, and we're trying to find where they intersect. So that's our real question, is where do these functions intersect? That's what we're trying to answer here. And in that case, that's going to be where is x in both of these going to give us the same y? So what x is going to give us both the same y? And we do so by substituting one into the other. So we're going to take x plus 1 equals 3x minus 7. We can do that because they both equal y, and if this one equals y and this one equals y, then we know that they are both equal, right? If a equals 1 and c equals 1, then I can say 1 equals 1. Or I can say that a equals c, I guess is a better way of looking at it. So it's that transitive property, just substituting one into the other. Once you get to this point, it's like we did last chapter. We solve for x. You need to get x on one side. So you can either bring 3x over this way, or you can bring 1x over this way. I'm going to subtract 1x from this side, so I'm going to subtract the 1x here. If I do it to that side, I do it to this side as well. And in this case, this is going to cancel, leaving me with a positive 1. And over here we have 3x minus x, which will give us 2x. And then we just tack on a minus 7. And then we can solve for x here by adding 7 to both sides. Remember, do your order of operations in reverse, and you're doing inverses. So we're subtracting 7 here, so let's add 7. And I'm going to add 7 to this side as well. 1 plus 7 gives me 8 over here, and over here this canceled. And that leaves me with 2x. Then to continue to solve for x, again, order of operations in reverse, I'm going to divide this by 2 and divide this by 2. This will cancel, leave me with x, and 8 divided by 2 equals 4. So my x value here, for where they intersect, I know the x value is going to be 4. However, I still don't know what my y value is. So I got to figure out my y value. And that's pretty simply done by taking your x value that you figured out and plugging it into one of these two equations. It doesn't matter which one. We'll go ahead and do both of them to show you that, but we have y equals 4 plus 1. In this case, you're going to get y equals 5. And in this case here, we would have y equals 3 times 4 minus 7. 3 times 4 is 12 minus 7, which is 5. So we still get 5 for both of them. So we know our y value here is 5. So where do these two lines cross? They cross at 4, 5. Again, you can do that by graphing. Let's go ahead and graph it just to check our work. In our graphing calculator, we're going to get y equals, we'll type x plus 1, and in the second y equals, we'll type in 3x minus 7. Go ahead and graph it, and you'll see these are what the two lines look like. You do see they do intersect. They are not parallel lines because they have different slope and different y-intercepts. And we can hit second calc, or second trace, which is the calc function. And go down to intersect, select both our lines and tell us where they intersect at, and it's 4, 5, which is where we got. No, this is not number 1. This is just a random problem I chose. I can do some on the sheet later. Once I get through the next one, I'll do some from the sheet if you have questions on that. But let's look at number 2. Number 2 is done a little differently, but not much differently. You'll note that one of these equals y and the other does not. So I can't set these two things equal to each other because they aren't equal to each other. It doesn't say that. But what I can do is I can substitute in for this y here. You'll note that this here equals y. So anytime I write y here, I could be writing this instead. So here it's going to say x. I'm going to start with this one and put y in for here. So it's going to say x plus, instead of writing y, I'm going to write 2x plus 5. 2x plus 5, which is equal to y. They're the same thing, equals 8. And in this case, I really don't need the parentheses, but I put them there just because to show you that it came from here. But in this thing, you can combine like terms over here. You don't have to actually do what you were doing over here, bring one x to the other side. All your x's are already on this side. So we can just substitute right into that y. So x plus 2x gives you 3x, and then plus 5 equals 8. And in this case, just solve for x. So subtract 5, this gets you 3x. This gets you 3, divide by 3, x here equals 1. And that's going to be true for both of them. So our coordinate is 1 comma something. That's going to be true for both of them. So you go ahead and plug in x for one of these. Now when it comes to plugging it in, again, it'll work for either one, so choose the one that makes more sense. You can plug into this one here if you want, but then you got to do your algebra to solve it. Or you can plug into this one here and just solve it. Either way really is going to work, and if you're comfortable with the algebra, go for it. I just think this is probably easier. So let's go ahead and plug it into that. Y equals 2 times 1 plus 5. So x equals 1, so instead of writing x, I wrote 1. 2 times 1 is 2 plus 5 gives you 7, so y here equals 7. And it would have worked for this one too. You would have get 1 plus y equals 8, and then you subtract 1 from both sides, and y equals 7. So it still works for both of them, but you have to plug into here. Now this one here is different than this one here because this is actually in standard form, not y-intercept form, or slope-intercept form, sorry. That's what we know it as. Slope-intercept form. It does not look like y equals mx plus b, right? It looks different. So one way to do that is to just substitute this one in for this one. The other way to do that is to actually rewrite this so it is in slope-intercept form. And we can do it that way as well. It's just probably a little more work. Oh, I deleted everything. So let's, there we go. Let's just take this. Cut that out and then delete everything and bring it back. So I could also have just rewrote this function so it equals y. I could have done the algebra here, and I could have been like, well, I want it to equal y, so I'm going to subtract x from both sides. So now it becomes x equals 8 minus x, or y equals 8 minus x. And then I could set them equal to each other, so 2x plus 5 equals 8 minus x. Bring your x's together. I can bring 2x over or 1x over this way, so let's just add the x plus the x, and this is where you get your 3x plus 5 equals 8. So you would have gotten it anyways doing it that way, but it's probably easier to just plug that one into this one. But it's whatever you're more comfortable with. Some of them, and I think the first one is set up this way. Some of them, neither one of them are equal to x. So this is from the sheet, Jason. So 3x plus y equals 15. We can do this one together. See if you guys are on the right track for things. And again, our numbers, I picked ones that the numbers might not necessarily be nice, because it's really going to challenge you that way. But here, neither one of them equals a variable. So we got to solve for one of these variables on one of them. It doesn't really matter which one it is, or you could do both. This is a y. I'd pick whichever one you're more comfortable with. Probably this one up here, because y is already by itself, so I don't have to divide out by it. But I can solve for y here, or you could have chose this one here and solved for x. Either way, you need to get it so one of these equals a variable. So I'm going to go ahead and take the 3x plus y equals 15, and I'm going to solve for y. So in order to do that, I'm going to subtract 3x from both sides. Right, I'm adding the 3x. This is a positive 3x out here. This is a plus sign implied here. So I'm going to add it. That's going to leave me with a positive y equals, I'm sorry, I'm going to subtract it because I'm doing the opposite, equals a negative 3x plus 15. Now once I get this, I can take this one and plug it into here because I know what a y equals. So I'm going to take this y right here and substitute it in with this. So it's going to be x plus 2 times the quantity, negative 3x plus 15 equals 10. Now just be careful here because this is your distributive property. So you need to distribute in order to solve. So you're going to be doing 2 times negative 3x, which is going to be, well, we're not touching this x. 2 times negative 3x is going to be negative 6x. And 2 times positive 15 is going to be positive 30 equals 10. And then you can clean up your signs here. This is just going to be subtraction. Right? And then you can continue solving for x. So it is taking what we did last chapter and applying it here as well. You got to keep that together. Here we have x minus 6x. We have x minus the 6x is going to give us a negative 5x plus 30 equals 10. And then we're going to subtract 30 from both sides. Because again, order of operations in reverse, so this was combining like terms. Over here we're going to get 10 minus 30 gives us a negative 20. And negative 5x equals negative 20. Divide each by negative 5. Divide by negative 5. You're going to get x equals positive 4 because again, this is a negative and this is a negative, and a negative divided by a negative gives you a positive. So I know that my x value is positive 4. So when I come to my point, I know that's going to be a 4. I don't know what my y value is yet because I got to take this 4 and I got to plug it back into one of these two equations. Again, it's not going to matter which one you plug it into, whichever one you feel more comfortable with. Let's do with the first one. I mean, we even rewrote the first one, so you could plug it into this as well, because that is the first equation, just written differently. But let's just plug it right into the first equation, which is 3x plus y equals 15. And I know my x is 4, so I'm going to take this x out and call it a 4. The homework is the worksheet from yesterday, Anthony. Again, that's going to be the homework for today and tomorrow as well. And I'm not sure if I'm giving you anything Friday. Tomorrow we're going to look more specifically at word problems, though. So keep that in mind. 3 times 4 gives you 12 plus y equals 15. Subtract 12 from both sides. Draw the line if you need it. I'll put on the equal sign. This equals y equals, and then 15 minus 12 gives you 3. So your point is 4 comma 3 for this one. So this does take a little rewriting of an equation in order to plug it in. But once you plug it in, it is really done the same way as before. Don't forget, you might have a distribution thing. I like to put parentheses around anything that I substitute into. just because it separates things, and occasionally it does have an effect, such as the distributive property here. It showed up easier when I put everything in parentheses, and I didn't just tack on 2 minus 3x plus 15. Then I would have thought, well, it's 2 minus 3x, but it's actually multiplied by the whole quantity. So just a tip, if you want to put things in parentheses easier, anytime you substitute in. For example, here it wasn't really necessary. It was just 3 times 4 anyways. But here it was. So just to play it safe, when you substitute in, put things in parentheses. Did anybody have questions about any of the problems they did yesterday? If they want me to look over one that they might have done or check it. Some of them were kind of tricky. Again, number 2, if you want to look at number 2, you should be able to do all the ones with the exception of the word problems right now. I mean, you can probably give the word problems a shot, but you're going to have to be careful about how you write your equations. That's going to be the next new thing. But number 2, again, like we discussed today, you have 2x plus 2y equals 18, and you have x plus 3y equals 17. In fact, this one might be easier to solve for x first and then solve for y using your things, but we can keep it together and do it for y still. It's probably just as easy to do one as versus the other. Let's go ahead and rewrite this one. When we rewrite this one here, we're going to get y by itself, so we're going to subtract x. Subtract x, so we get 3y equals 17 minus x. And watch your fraction work here. Divide this by 3, divide this by 3. So we have y equals 17 minus x divided by 3 as your equation. It might be nicer for you to separate out that denominator. I don't remember. I think if you want to keep things fraction-wise, this is nicer to separate out, but you can separate it out that way as well. And once you've rewritten that, you just plug it in for the y here, which is going to be a little difficult for you to solve. So let's look at what that's going to look like. I'm going to plug it in. So it's going to be 2x plus 2 times the quantity 17 divided by 3 minus x divided by 3 equals 18 here. I guess we can end our parenthesis. Equals 18. So again, you have your distributive property here. So this is your distributive property. You distribute the 2 to each. So in that case, you get 2x plus 2 times 17, which is 34 over 3, minus 2x over 3 equals 18. I'd have to look at it, John. Let me finish this one first, because this one does get tricky. Right? Now, to get rid of this denominator, the best way to do it is just go through and multiply everything by 3. But if you're going to do it on this side, you're going to do it on this side as well. So think about, hey, we're going to group this all together, and we're going to multiply it by 3, and that's going to get rid of your denominator. But you got to multiply this side by 3 as well then. So go ahead and do that. 3 times 2x is 6x plus, and then it's just going to get rid of your denominator. So it's going to be 34 minus 2x equals, and then 18 times 3 is, oh, that's not what I wanted. 18 times 3 gives you 54. So that's one way to deal with your denominators. So those will cancel, but you're still going to have to multiply this one by it, and you're still going to have to multiply this one by it. So just be careful with it. You can multiply through by your denominator, though. And we can combine like terms. 6x minus 2x gives us 4x plus 34 equals 54. Subtract 34, subtract 34. You get 4x equals, and then what is that, 20? Divide by 4, divide by 4. So here x equals 5, which is a nice number. And then you just plug it into one of these and solve. We can go ahead and plug it into, I mean, you could plug it into this as well and do 17 minus 5 divided by 3 if you wanted, which is probably the easier way of doing it because we did transform that. But then you got to trust that you transformed that correctly, and that's not where you made your mistake. So plugging it back into one of the original ones, you can do 2 times 5 plus 2y equals 18. 2 times 5 is 10 plus 2y equals 18. Subtract 10, subtract 10. 2y equals 18 minus 10 is 8. Divide by 2, divide by 2. Y equals 4. So in this case, for number 2, you should be getting 5 comma 4. The trickiest part here is probably the denominator work here, but you could have done this otherwise. You could have just kept them like this and worked with the denominator. That would have worked out well too, but just multiplying by 3 on both sides will get rid of it. But again, just remember you got to do it to both sides. You got to do it to the whole quantity. So the 2 got multiplied by 3 as well. That got multiplied by 3, that got multiplied by 3, and that got multiplied by 3. That's where the 6x comes from, and then when you multiply with the denominator, they cancel. And you get that. So hopefully that worked out well for all of you and you're able to follow that. Jack wants to do number 6. I don't know what the answer is off the top of my head. I don't have my answer sheet with me. 1, 2, 3, 4, 5. Lost count. I should have numbered these. 1, 2, 3, 4, 5, 6. This is the fraction one. So 6, we have y equals negative 1/2 x plus 4, and y equals negative 4x minus 5. So they are equal to each other. You can set them equal to each other, so it's going to be negative 1/2 x plus 4 equals negative 4x minus 5. If you don't like the 1/2, you could multiply everything by 2 if you really wanted to. But 1/2 is pretty easy to deal with as well. Anyways, you want to get your x's by themselves. So here we're going to, you can either move the 1/2 over or the negative 4 over. I guess it's really up to you. I'll move the 1/2 over. So I'm going to add 1/2 x plus 1/2 x. This is going to equal 4 equals, and then negative 4 plus 1/2 is 3.5. I'm just going to make it the decimal. 3.5 negative 3.5 x minus 5. Then go ahead and solve for x. We can add 5 to both sides. You get 9 equals negative 3.5x. Divide by negative 3.5. Divide by negative 3.5. Which I don't know off the top of my head. 9 divided by 3.5 gives us negative 2.57-ish. I'll round it. You might have rounded that too. I don't know if that's where you're getting your negative 2 from. Equals x. So that's what I'm getting for my x value there. Then I'm going to plug it into one of these. So I'll use the other one. Negative 4 times negative 2.57. Again, that's rounded. Minus 5. So let's multiply that by 4 and subtract 5. I'm getting y equals 5.28. So maybe, Jack, it's not looking too good for that. We can check this on the calculator. Let's see who did it right. Let's see if we did something here. Maybe moving that negative half over and gave you a bump or something here. Negative 0.5, which is a half, x plus 4, and we're going to graph that with negative 4x minus 5. I did copy that, right? Didn't I? Yeah, okay, I'm going to graph it. Second calc, intersection between that line and that line, we are getting, yeah, I'm getting the same answers I got. My x value is negative 2.57. X value is negative 2.57, and my y value is 5.28. So that's what I'm getting, Jack. I'm not sure if you can find your mistake in there. I would assume it is the work with a negative. Negative 4 plus a half is going to give you negative 3.5. Either that or they're rounding. Because if you rounded this to 2 or negative 2, what would you get if you rounded that to negative 2? Negative 2 times 4. Yeah, if you rounded this to negative 2, that probably did it. 4 times 2 is positive 8 minus 5 gives you that 3. So that might have been what it was. You might have just rounded this to 2. Did you round this to 2? Is there a number up here that you don't know where it came from that I can help you with? I'm sorry, I just hit my mic. You have no idea. Okay. You want me to walk you through it again, or do you want me to walk you through another one? Did it yesterday? Yeah, I expect a lot of people to get these wrong the first time they do it. This is not easy. It really isn't. There's a lot going on. There's a lot you need to notice. That's why I plan on spending 3 days on this. But let me see if I can find my answer sheet. Pretty sure I had the answers to these somewhere already. I might have to make them. I'm just saying if I can give you the right answers, you can check to see if you're doing them wrong. Yeah, I can look at number 8. That's the y equals 2x plus 3 and y equals 0.5x minus 2. Again, they're already both equal to y, so you can set them equal to each other. So we can get 2x plus 3 is equal to 0.5x minus 2. And then you got to bring your x's together. So whichever one you're more comfortable with, subtract 2x from both sides or subtract the half. I'm going to subtract the half, so minus 0.5x. Bring the x with you because that's the whole idea. Minus 0.5x. Again, that's a positive, so we're doing subtraction. 2 minus a half hopefully is giving you 1.5x plus 3. just bring down this plus 3. This will cancel and leave you with -2. So hopefully you're good so far. Then you just do your algebra to solve for it. I'm adding 3 over here, so let's do the inverse and subtract 3, subtract 3. Watch your integer work. This is a -2 minus 3, so that should be a -5. And we got a 1.5x equals -5. And then you go ahead and divide by 1.5, divide by 1.5, and x is going to equal whatever -5 divided by 1.5 is, which is -3.3 repetend. And again, that repetend just means the 3 goes on forever. So there's your x value. So I know my x value is -3.3 repeating. Or you could say it's -3 1/3. If you're happy with the fractions, it doesn't matter. I'm going to keep it as a decimal. And then you just plug it back into one of these. Probably the easiest is the first one, so you don't have to deal with a decimal. So you're going to get y equals 2 times -3.3 repeating, which is your x value, plus 3. So then go ahead and multiply that by, screw that up. Is that -3.3 times 2 plus 3 gives me y equals, see, this times 2 is going to give you -6.3 repeating plus 3. When you add 3, y is going to equal -3 point, I'm sorry, 6 repeating. So I'm thinking -3.6 repeating. I lost the number in my calculator there, so I might be off. Let's go ahead and check it. Turn that on. Y equals, get rid of that, get rid of that. Here we have 2x plus 3 and 0.5x minus 2 graphics. It's looking like in the right area. Find the intersection between those two, take a guess, and there you are. You're getting your x as -3.3 repeating and y is -3.6 repeating. So that is a correct answer. But it is going to come with practice, and again, I did give you tough ones to solve, so try it out. Tomorrow I'll give you the answers to the number ones, and we'll look at some word problems. Do you have any other questions? So give some that you have to kind of move your equation around a bit to try. Yeah, it comes with practice. It's not an easy thing. It's definitely not easy. I will give you that, Jack. It's especially when I give you things with fractions and stuff to start off with. I gave you some tough ones to start here. All right, if there's no more questions, I'll give you another chance to sweat some of those out and get answers. I will give you answers to them tomorrow to see how well you guys pull them up. I just got to find my answer sheet. It's titled something different. and I forgot what I titled it, so it's hard to search for it right now. But I'll give you some answers to that, and we'll look at some word problems tomorrow. Word problems are really the same thing, only you got to make the equations yourself out of them, and once you start making equations with words, it's not difficult, especially if you can realize what slope is. Can we do 3? You want to do 3 real quick? Yeah, I got 5 minutes. I can do 3. 3 says x plus 6y equals 32, and x plus 3y equals 17. And again, you got to get one of these to equal a variable. It could equal x for all I really care, and solve for the y first, which we haven't really done any like that, but technically it'll work. But let's solve for one of the y's. It's really your choice on which one you want to do. Just watch your fraction work, because you are going to get some ugly fractions here when you do solve for y. So I'm going to go ahead and just take the second one. You could have did the first one, it doesn't really matter. But I'm going to go ahead and take the second one, and we're going to get x plus 3y. I want to get y by itself, so I'm going to subtract x from both sides. So I'm going to get 3y equals 17. I did copy the right one. Oh yeah, it's the same equation from number 2. So if you already converted it for number 2, you got it for this one now too, actually, if you want to do it that way. X, and then you can divide by 3, divide by 3. So this is actually going to equal y equals 17 minus x divided by 3. With that, you're going to go ahead and substitute this in for y. Now don't forget your parentheses here, because you are going to have the distributive property there. So 17 over 3 minus x over 3. And again, you can break that apart, 17 minus x. If you want to write it as common denominators of 3, it might be helpful. It might not. Depends on who you are, I guess. I don't know. And that's going to equal 32, because we're just going to multiply through by the denominator, getting that anyways. But we can go ahead and distribute the 6. I don't know what 6 times 17 is, but we get plus 6 times 17, which is 102, divided by 3 minus 6x divided by 3 equals 32. Go ahead and multiply out by the denominator. Multiply everything by 3. That's going to give you 3x, because 3 times x is 3x. 3 times 102 divided by 3 is just 102. That's why we're multiplying it by 3. This is a negative. Watch your negative. 6x times 3 divided by 3 is just 6x. That's why we multiplied it by 3. Equals, and then 32 times 3 gives us 96. So hopefully you understood the getting rid of the denominator. Again, I just chose 3 because that was my denominator. And again, if I'm going to multiply this side by it, I have to multiply this side by it as well. You get really good at that, you'll be awesome at completing the square next year, which is probably the hardest thing that we cover next year. Over here we get 3x minus 6x is going to give us a negative 3x plus 102 equals 96. Go ahead and do your algebra. Subtract 102, subtract 102. Watch your signs, because that will be a negative now. We get this as negative 6, and we have negative 3x, and I ran to the bottom here, but divide by negative 3, divide by negative 3. You're going to get x equals negative 6 divided by negative 3. They're both negative, so that becomes a positive, and that's a 2. So x equals 2 here, which is a nice number to work with. So 2 is our first one, and we need to figure out y. So pick one to go into. Let's pick the first one, I guess. X is 2 plus 6y equals 32. You got it from there? I'm going to finish it, but if you want to go ahead. I'll just finish it for the record. I'm going to then subtract 2, you get 6y equals 30. Divide by 6, divide by 6, y equals 5. So you get 2, 5 is your answer. But yeah, it's just kind of doing little algebra stuff we've been doing all year, kind of combining everything together though. So try to keep things straight, try to keep things organized, and give it your best shot. Again, I will give you answers to things tomorrow, and we'll do some word problems tomorrow. So I'll talk to you later. Bye.